Can you explain the value of NFPA 70E's 130.7 table?
This one's huge. I have in my backpack over here, I have NFPA 70E books from 2004 when I got my first one.
Okay.
And it is amazing. My 2004 book, by the way, I was looking over the weekend. There are no highlights, there's no underlining it. I don't even know if I read it. But that's when I was kind of diving into the electrical safety industry. I used it as my guidance. And it is interesting, back then, the 130.7 tables were multiple pages. And now we're down to, what, 3/4 of one page? So the tables have definitely shrunk. But for those of you that are unaware of what the 130.7 tables are, let me just kind of basically line this out. You have an electrical worker, and this electrical worker is walking up on a panel. They're going to open up this panel. They're going to do energized work. Let's just say they're going to troubleshoot. And the idea is that on the outside of that panel is a label, and that label tells them what type of PPE they need to wear. So that's what we call a arc flash label or a hazard label, and it helps the person determine what level of PPE they need to suit up in. And so that's the purpose of the arc flash label. The 130.7 tables are there in case you don't have that label in front of you. If you don't have the label in front of you, there is no label in the equipment. How do you suit up? And I love when I'm talking to somebody who just doesn't know, right? And we talked about this earlier. They don't know. They'll say, oh, we're going to suit them up. And I always love to say, well, to what level? And they're like, well, we're going to put an arc flash suit on them. Well, is that 4 calories? Is that 8 calories? Is that 12 calories? Is that 25 calories? Is that 40, 65, 75, 100, 140? I mean, and they look at you, this deer in headlights, like, there's that many options? Well, sure there are. And there's even some that I didn't name. So what happens is, and this was NFPA's desire for the 130.7 tables, is that you can pull open the book and get an idea of what it is that you should be prepared for. In other words, what level should you suit up to protect yourself from an arc flash?
So that's you're going pretty deep with it, which is great. But I want to ask you, bring it down a little bit,
Okay.
because I want to ask you, what have you seen in the marketplace with customers
Oh.
when somebody? I'll tell you that I've seen going into conversations, and I'll walk past a piece of equipment that has a label on it, and I'll ask a safety personnel, what does this tell you?
What's the answer?
It's all over the place. It is absolutely all over the place. Somebody tell me, well, I mean, I've had things go as far as, well, we need protection against 480 volts for our clothes.
Okay.
I
Still
mean,
didn't answer the question.
No, I'm like, what does it do? So the intent is good with the tables to tell you what you need to have. The labels are good.
Right.
But my question is, how can we help the marketplace understand that and continue to bring awareness, because people just don't know what they don't know.
Yeah. And this is there's a human nature aspect to electrical safety that's rarely mentioned. And it's human nature, if I don't have something clearly in front of me telling me to change my behavior, I'm just not going to do it. I'm just going to continue on. And that's been one of my concerns for people who say, well, the tables aren't that accurate. They're overprotection to the nth degree. And maybe that's true. But the reality is the tables give a worker a fighting chance to protect themselves. Now, the problem is there's two major caveats to the tables. And you know this as well as I do. You've got to know the available fault current, and you have to know the available fault clearing time. And nobody has that information. There's not a label in there saying so much available fault current, so much available fault clearing time. So what happens is people have to basically guess. Now, I've been told I have to be careful with what I say when it comes to NFPA 70E 130.7 tables. And one of the things that's kind of a simplified answer, if you don't know, you assume the worst. Well, what is the worst when it comes to NFPA 70E? Well, it happens to be a 40-calorie suit. If you go through the 3/4 of a page of 130.7 tasks, and you find a task that's similar to what you're doing, it'll tell you what the available fault current max is. It'll also tell you what the available fault clearing time max is. And then that tells you what PP to select. Well, if you look through that table, you see a lot of 2s and a lot of 4s. And PP category 2 is 8 calories. PP category 4 is 40 calories. So, and I always, when I'm teaching the class, I'll pull up the 600 volt switchgear, and then I'll say, well, here's the parameters it has to match. Well, nobody knows the parameters, and it gives 2 different options. PP category 2, which is 8 calories, PP category 4, which is 40. Same piece of equipment, just different parameters. And I'm like, well, if you don't know the parameters, which one do you pick? Mm-hmm. So now where I get into trouble with the 130.7 tables is I have to be cautious, because there is no substitution for knowing specifically through an engineering model called incident energy what could come out of that equipment. There is just no substitute for it. The 130.7 tables attempt to be a substitute. And where I get into arguments with companies are, okay, I recognize that you don't know the fault clearing times. I recognize that you don't know the available fault current. So if you look at worst case scenario in NFPA 70E, 130.7 tables, it's a 40 cal suit. And they're like, well, what if that's not enough? And I'm like, what were you going to do without that information? And the answer is human nature was going to dictate that they just went in and worked how they were dressed. Mm-hmm. And that's a huge problem. So,
well, I'll go kind of on the other piece of the information. You're talking a lot about the incident energy and what you need to be in from a calorie perspective or a protection standpoint. I'm going to go into the voltage now, because you hear a lot of companies out there today saying everything in here is 480 and below, right? We've got it down to 480 and below. Great. My follow-up question to everybody is, what about that 1 or 2 piece of equipment that's 600 plus?
Yeah.
And most of the time, the companies, when they go back and look at their assessments, they have that 1 or 2 pieces of equipment that exceeds 480.
Right.
So what do? And where I'm going with this is, when you get into the voltage-rated gloves, the double aught goes to 500 volts. Right? The single aught goes up to 1,000 volts of protection. What we are seeing, and the awareness I would like to bring, is that a lot of companies out there will go ahead and put their employees across the board in class single aught gloves, to protect them against everything in that facility, which makes sense, right? It's the highest voltage they can get. It's not putting the choice of which gloves to wear based on the employee or whoever it is, with that the lower level voltage, right? Because both double aught and single aught gloves, the price is pennies difference. The dexterity is very minuscule. It's not until you really get into that class 2 glove, where it's twice the amount of rubber, 2 inches longer, gets up to 17,000 volts of protection, but the dexterity is just not there. You can't do anything with it. And so that's the kind of things that, even though it sounds basic, what I found when you walk up 2 pieces of equipment with people all across different industries, they just don't know the answer.
So I want to kind of pursue this idea of where the 130.7 tables play the most important role.
Okay.
So if I'm a captive worker, so I'm working for ABC company, I'm a maintenance guy, that company's burden of responsibility is they've got to tell me what level I've got to protect myself to. That's the arc flash label. And then they've got to provide me with that PPE. That's very common knowledge. Most people get that. The problem is there's another question I read earlier that's going to come across the table today probably, and that is, who's at risk? And so in the first case, where I'm a captive worker, there should be pressure on the employer to put the labels on there. And because they have the same people, their employees, day in and day out on that equipment. The problem is when a company says, oh, we don't have any of that skill set here. We don't have those maintenance people that are authorized to work. And so then my question is, what do? We hire electrical contractors. Oh, How do they know to protect themselves? Well, they're electricians. They should know. And I'm like, there's no way to know. This is where electrical contractors rely on that 130.7 table because they have no clue. And the employer or the company who owns the equipment is like, we don't have our own employees in front of it, so we don't have to do that expensive arc flash labeling.
Right.
And the reality is, so I see the 130.7 tables really coming into play for electrical contractors a lot because typically speaking, an electrical contractor wears daily wear like what you're wearing at a minimum of 8 calories of protection. But we know, and there was an incident that you and I are involved with last year. Now, we weren't involved in doing the work, but on the back end, on the investigation side, there was a guy who was hit wearing 8 calories daily wear, and he caught fire and nearly died. If it hadn't been for somebody with a fire extinguisher close at hand, he would have died. And the question from the management team was, he was wearing arc flash PPE. How did that happen? Well, it happened because there was no label on the equipment. Bowtie Engineering came in later, a couple of months later, did the labeling on all that equipment, and we found out that piece of equipment was 88 calories. Ooh. So 11 times greater than what he was wearing. But management said, we put him in arc flash PPE. So this is why I see the 130.7 tables leads us down a road that we would not go otherwise without that information. So I'm a huge fan of the 130.7 tables. I'm a huge fan of extrapolating information in the absence of any other instructions. So if I walk up on a piece of equipment and there's no label, to me, I'm going to put on a 40 cal suit. Now, you put your workers in 40 cal suits every day, and you're going to get a lot of pushback because they're not well, they are restrictive. They're hot. Nobody likes to wear them, typically speaking. So this is why I think those 130.7 tables are so important, because if I didn't have that in the back of my mind, I may be tempted to work just like I am now. There's no label to tell me otherwise. But this shirt, it's all nice and cool. Mm-hmm. It's 100% polyester. This gets hit by an arc flash, it's going to ignite like a Roman candle. It's going to stick to my skin. I'm going to have a gooey mess on fire on my skin. And that's a recipe for disaster and a formula for a fatality.
Well, I think this conversation goes back to just greater awareness, because even in the example you just gave, where you had someone wearing arc flash daily PPE at 8 calories, and they got hit by, what'd you say was
88 calories.
88 calories. The instance of what you said, going to, if I don't see a label on it, I'm going to put a 40 cal, that wouldn't have even been enough.
There's a couple of people in the industry that I trust, and one of the guys is Hugh Hoagland.
Okay.
Hugh Hoagland was kind of the spear tip to the NFPA 70E arc flash movement. He's since retired. He owns a company called eHazard. I will tell you, Hugh and I sat down years ago, and I hate to name drop, but he gave me the authority to do this. And I asked him, Hugh, have you ever been aware of somebody killed wearing a 40 cal suit? And he said, now that I think about it, and he has done hundreds, if not thousands of investigations.
Right.
He said no. And so I tell people that there is a magic to a 40 cal suit. Now, please don't get me wrong. There really is no substitute for incident energy labels on equipment with properly trained employees. People that know how to read that label, know how to select the PPE and protect themselves. However, if you don't have that information and you've got to go work, and I get this a lot, hey, we got a project this weekend, we don't have any 40 cal suits, they're telling us we need to have one, but there's no labeling on the equipment. There is a magic to a 40 cal suit in the fact that it's a multi-layer suit. There's a worker on the East Coast that was hit a few years ago with over 100 calories. Now, he didn't know it at the time. The equipment wasn't labeled, but he happened to be wearing a 40 cal suit. And the first picture I got was of the destroyed hood. I saw that and I was like, oh, now we have somebody dead wearing a 40 calorie suit, because I saw what was left.
Right.
There was not much. The suit was charred remains. And I'm like, where's the body? Because they had the suit laying on the asphalt in the parking lot.
Oh, wow.
And I'm like, where's the body? And they're like, no, he's alive. He didn't get any burns. And I'm looking at the suit and it's like, how's that even possible? Well, remember, at the time, we didn't know what the incident energy was on that equipment. It came out about a year and a half later that was 104 calories. And he was wearing a 40-calorie suit. So our mind says there is no way that protected him. Was it just the luck of the draw? But here's the significance of a 40-cal suit and above. It's a multi-layer suit. So as it caught fire, and it did not self-extinguish because the incident energy was far greater than what it was rated for, it continued to burn. But as it continued to burn, it gave him an escape path to get out of it. So literally, while it's burning through its layers, he's taken the suit off. He gets it off his body, and he had no third-degree burns. As a matter of fact, he was only in the hospital for a week, and he returned to work a week later. So when I saw the pictures of the suit, and I was like, there is no way somebody survived that. So this is where I started to get the idea that there is magic to a multi-layer 40-cal suit. And then Hugh Hoagland confirmed that a few years ago. We were sitting, maybe drinking a bourbon in Houston, and came across that idea.
I'd be interested to know, was that individual wearing daily wear
Yeah,
underneath?
I don't
do you
even know.
That?
Yeah, don't even know. So I just saw the three pictures of the suit, and I was 100% sure that somebody was dead.
Well, arc flash suits are just interesting. I've been doing some work on the task group with one of the ASTM committees on
Right.
that for a new standard that's coming out. And if you look at arc flash suits pre-pandemic, is what I'll say.
Okay.
Typically in MCC and control rooms, people would come in, maybe have a size or two in there. They'd pick which one kind of works for them. They'd put it on, take it off, do what they got to do, right?
Right.
Leave it in there. Didn't matter what kind of condition they were in.
Right.
Those suits really became living, breathing petri dishes, is what I call them.
100%, man.
I mean, all day. The state of those suits that I've seen in my career has just been atrocious. I mean, they're
Right.
everywhere.
Right.
Let's fast forward post-pandemic. Personally, I've been involved with a lot of phone calls where people are saying, can you help us get these things cleaned? We don't want to share these items anymore.
Hallelujah.
Right? We want them cleaned so that they can actually do what they're supposed to do at the right time and people feel comfortable in
Right,
them.
right.
And so even we talked about PPE earlier, or garments, I'll say earlier, with this sort of primary protective arc flash suit, making sure it's cleaned, repaired,
100%.
in tip-top shape. Because if it's a primary garment, primary protective garment, we really want it to do what it's supposed to do
Right.
in the event, that example you were given earlier.
Right,
So
right.
I think there's a lot of different options, and you talk about advancements. Before people would just purchase those things, couple $1,000 things, but now there's more options. You can still do that, but you can also have them taken care of for you.
Right, right. And that's, we could probably talk for hours on PPE. So just for the audience, for y'all to know, arc flash PPE doesn't work the way people think. A lot of people assume that it deflects the heat or reflects it. The heat moves around. The way they work is they catch fire and they self-extinguish. And the manner in which they self-extinguish determines how we actually rate them. So that's one of the big benefits that we have when it comes to arc flash PP. I have heard so many companies say, well, all we have is 480 volts. We don't have what the utilities have. We don't have 15 kV, 4160. We don't have any of that. We just have 480.
Okay.
And 2 weeks ago, I was in northern Alabama at a facility doing a plant walkthrough. And I've learned this over the years to ask the safety person, what equipment scares you the most? And I know you and I were doing a plant walkthrough earlier this year or late
I
last
remember
year.
that, yeah.
And we heard the safety guy tell the maintenance guy that was assisting us through the facility, don't take them up to the mezzanine. So as soon as we got out of earshot with the safety director, we were like, all right, let's go see the mezzanine. He goes, oh, and what we saw up there was very evident as to why the safety director did not want us to see it, because it was horrible. I mean, it's just, and imagine the biggest bird's nest of high voltage wires you can imagine, and that's kind of what the mezzanine was. So going back to this thing in northern Alabama a couple of weeks ago, I asked the safety director, I said, hey, what scares you the most? He goes, oh, and they had a mezzanine too. He goes, the equipment in the mezzanine. So just for the audience, the utility was supplying power to the facility. It was coming in at the mezzanine into their primary switchgear, and they were branching it off all throughout the facility. And so I walked up and looked at some of their gear. The first piece of equipment I looked at was 480 volts with 146 calories per centimeter squared incident energy label on it. And when I saw it, I asked, can I take a picture? And they said yes. So I took a picture of it and just the label. Didn't want to reveal anything about who it was or the company. But the problem is there is no PPE that allows you to work on 146 calories. The highest rated suit in the world is 140 calories. And I'm not sure you want to wear that. I'm not sure you ever want to expose. I mean, and we'll have a whole conversation on line in the sand. So one of the things that I realized is that some companies, because of the early on focus of OSHA and NFPA 70E, tended to focus a lot on utility level connections and utility level supply. And so you get people say, well, hey, that's an arc flash for 15 kV. We don't have that here. But then you look at a 480 volt circuit with 146 calories calculated. That's scary. And that flies in the face of what people think. Oh, I actually met a guy here in Dallas, very well known in the industry, and he had developed a matrix. And he was telling me, he goes, yeah, I developed a matrix for our at-large workers. So at-large meaning electrical contractors. I'm like, okay, can I see it? He goes, yeah. Pulls out this nice laminated color-coded matrix, and I'm looking at it, and it says if you're exposed to 480 volts, then you have PP category 2, which is 8 calories. So, and I'm like, well, where did you get that from? And he's like, somewhere off the internet. It must be true. So I'm like, that's not true. And this is one of the problems in our industry is that sometimes people say, well, we're only 480, 208. We don't have those high voltage levels or that high. You could, and you won't know until you do the calculations.